also the problem, guys, can be presented as they give you some bunch of molecules or atoms, and they want you to figure it out what's the mass of them. Well, all you have to do is pretty much, let's do example 9.12. On page 354. And let's see what's given. So what would be the mass in grams of nitrogen dioxide, NO2, sample in which 100 billion, so this is a given. This is a given. I have to take it as a given now. 100 billion. That will be, of course, and molecules, I suspect. Yes. So there's molecules here of NO2. So the question, of course, here is what will be the mass. So now we're going backwards from the original problem. The original problem had grams, and we had the molecules. Now we're going from molecules to the grams. So therefore, it's just the units will be now of conversion will be flipped, and let's see how it's being done. Okay, so anytime you guys read a problem, you always want to extract what's actually given, and always want to put it first on the, on your paper, on your board, and then from there you want to find out, okay, what needs to be found, and that will be just our unit right here. So okay, so what kind of conversion factors now we're going to use here? Well, of course we see moles in here, and we know that 1 mole is always Avogadro's number. In this particular case, it is a number of molecules of NO2. Okay, that's great. Now, but we also know that 1 mole of NO2, and we're now going to look at the periodic table, and get that molar mass of NO2, which will be molar mass of NO2, and we know how to do this. It's going to be 1 mole now of nitrogen, which 14.01 grams of nitrogen, 2 moles of oxygen, that will be your 32.00 grams of oxygen, and so when you add them all up, you get 1, 0, 6, and you get 4 in here, so it's 46.01 grams, and that will be of NO2, and that will be your molar mass calculated here. Okay, now, so I got now another conversion factor, which is 46.01 grams of NO2. Okay, so I think I'm equipped with everything to deal here to finally convert my molecules into the grams. So of course the first conversion conversion factor I'm going to use here, I need to match my units. There it is, so I know this is it, and not this, because this one does not have the units for me to cancel. And therefore I'm going to put 6.022 down to the positive 23 molecules of NO2. You see how I lined them up properly? Molecules will cancel. And then that will be equivalent to 1 mole, and I forgot here to put of NO2, of course, of NO2 times. So my last conversion, of course, will be, we need the grams, so this is my conversion factor number 2. This one I used up, I'm going to just cancel it. And so I'm going to do now 1 mole of NO2 is equivalent to 46.01 gram of NO2, canceled. All I have to do now is simple mathematics with my calculator to get to the final answer. Again, here are 4 significant figures, so my final answer should be 4 significant figures. And so let's do this. Times 46.01. And I got here 4 significant figures, of course, 7.640, 10 to the negative 12 grams. And that will be my final answer. And we can do one more problem here. But again, before I do it, just make sure you understand all of it. What we're doing here is conversion, which we learn, guys, conversion concept chapter 2. As I've told you over and over again, that's what you need to know to do these problems.